And we want to give you, the learner, the ultimate shortcut to being perfectly well-informed.
Without feeling totally overwhelmed by the technical specs.
Exactly, because CEO Jensen Huang is calling this a renaissance of enterprise IT.
It was an unbelievable spectacle, honestly. But once you strip away the flashing lights and the sheer scale of it all, what you're looking at is a fundamental pivot.
It's not just a defining moment for one company, right?
No, not at all. It is a complete rerouting of the trajectory of global computing.
Okay, let's unpack this, because the central theme of this entire multi-hour keynote is that Nvidia is no longer just a chip company.
Right.
They have officially transformed into an AI infrastructure and factory operator.
Which is a huge distinction.
It really is. They aren't just selling you a piece of silicon anymore. They are building the entire ecosystem.
From your local data center all the way up into, well, literal outer space. But we'll get to that.
Yeah, we will definitely get to that. But to understand what they are building, we really need to understand why.
And how much money is actually on the table here.
Exactly. So let's talk about the shift in AI. Up until now, we've basically been in this perception generation stage, right?
Yeah, which is essentially AI going to school.
Yeah.
It's learning how to think. It's ingesting the entire internet, recognizing patterns.
But that's a batch process.
Right. You train the model once over a period of months, and it's incredibly resource intensive. But it ends.
But that's changing now. We are moving into the inference execution stage.
Exactly. Inference is the AI actually taking the test. It's reasoning through a problem, making decisions, and acting in real time.
So if training is sending the AI to medical school, inference is...
It's the AI diagnosing a patient in the emergency room. And the emergency room literally never closes.
Oh, okay.
Yeah, inference requires an unrelenting, continuous flow of compute power. Millions of users asking millions of questions simultaneously.
And that transition is expensive. Huang doubled his previous demand estimates today.
He projected $1 trillion in cumulative order demand for AI infrastructure between 2025 and 2027.
$1 trillion.
It's staggering. And he kept repeating this core philosophy. He said, tokens are the new commodity.
Right, so data centers aren't places to store files or spreadsheets anymore.
No, they are literal factories designed to churn out intelligence. The token is the basic unit of that output.
Like a fragment of a word or a pixel.
Exactly. And Wall Street is totally buying it. Goldman Sachs already maintained a buy rating on Nvidia.
Because the massive capital expenditures from hyperscale cloud providers are cementing Nvidia's monopoly.
Right. The Amazons, Googles, and Microsofts.
So basically, instead of selling the engine, Nvidia is now selling the entire car factory.
That's a great way to look at it.
But I have to push back here. Is $1 trillion realistic?
You mean, is it just CEO hype to keep the stock price up?
Yeah. I mean, $1 trillion over just a couple of years sounds like a massive bubble waiting to pop.
It sounds like hype until you look at the underlying mechanics. What's fascinating here is that while 60% of revenue comes from those top hyperscalers,
Right.
the other 40% is rapidly diffusing into enterprise applications, edge computing, and sovereign clouds.
Sovereign clouds, like nations building their own AI.
Exactly, to protect their own data. So the demand curve is steepening incredibly fast. Inference is exponentially more demanding than training.
So you just can't run a global token factory on yesterday's hardware.
You really can't.
Yeah.
Which brings us to the machinery doing the heavy lifting.
Right. Huang literally wheeled this beast onto the stage, the Vera Rubin system.
It's insane. It's not a chip. It's a complete supercomputer platform.
It sounds like Nvidia is assembling the Avengers of computing.
Basically, yeah. The core is this NVL72 rack system. It integrates 72 Rubin GPUs with 36 custom-built Vera CPUs.
And those CPUs have these specialized Olympus cores, right?
Yeah, and they exist entirely to prevent traffic jams. The GPUs are so fast that traditional processors literally cannot feed them data quickly enough.
So the Vera CPUs just sit there, keeping the Rubin GPUs constantly fed.
Exactly, and the efficiency's wild. It takes only 1/4 the number of GPUs to train a massive 10 trillion parameter model now.
Compared to the previous Blackwell generation, right?
Right, which reduces the cost per token to 1/10.
That's a massive drop. But wait, here was the big surprise for me. The Grok 3 LPU.
Oh yeah, the Samsung connection.
Yeah. Nvidia makes their own chips. They're the undisputed king of GPUs. And they just bought Grok for $20 billion.
They did.
But Samsung is manufacturing the Grok chip. How does this asymmetric complementarity actually work in practice?
It's actually a brilliant division of labor. Nvidia realized their traditional architecture had a bottleneck with real-time conversation.
So how do they fix it without slowing everything down?
They use what they call the Dynamo Intelligence Scheduling System. Think about how AI processes a request. First is the pre-fill stage.
Like when you upload a massive legal document and ask for a summary.
Exactly. Ingesting all that is super memory heavy, so Dynamo assigns that to the Rubin GPU, which has massive memory.
Okay, so Rubin reads the encyclopedia. What does Grok do?
Grok handles the token decoding. That's the AI actually spitting out the answer, word by word.
Okay.
Doesn't need a lot of memory, but it's incredibly sensitive to latency. It needs to be instantaneous.
And Grok has that ultra-fast SRAM,
Yeah.
right? Delivering like 150 terabytes per second of bandwidth.
Yeah, it generates tokens at lightning speed without checking external memory banks.
So you usually have to choose between low latency and high throughput, but they're combining them.
Exactly. Rubin does the heavy lifting. Grok provides the lightning-fast reflexes. It's the holy grail of real-time AI.
Wow. And they even have Intel Xeon 6 processors in the mix for some rack systems.
Right, proving they'll use whatever silicon gets the job done fastest.
Okay, but here's where it gets really interesting.
Oh boy.
You cannot just plug a supercomputer that processes 60 exaflops of compute power into a standard wall outlet.
No, definitely not.
We are talking about gigawatt-scale factories. How on earth do you power and cool something that generates that much heat?
That is literally the existential threat to the AI boom, which is why Nvidia is partnering with Schneider Electric and AVEV.
To use those Omniverse Deus Ex blueprints, right?
Exactly. They create digital twins of these data centers before a single rack is built.
To simulate the thermal dynamics so the building doesn't just melt.
Basically, yeah. And the physical cooling tech is intense. They're using 480-volt AC power distribution,
And rack-level energy storage, like giant batteries right next to the servers.
which reduces peak current from the grid by 25%. But the craziest part is the warm water liquid cooling.
Running at 45 degrees Celsius, which sounds totally counterintuitive.
Cooling a computer with warm water, yeah. But because 45 degrees Celsius is about 113 degrees Fahrenheit.
You can actually cool that water using ambient outside air in almost any climate.
Exactly. You don't need massive, power-hungry refrigeration. The energy savings are astronomical.
Which brings us to the ultimate frontier. Huang announced the Vera Rubin Space One project.
Orbital data centers.
Literally in space. And I have to push back. I get needing efficient cooling on Earth, but why put a data center in space?
Because of satellite data.
But isn't Earth hard enough?
It is, but think about the sheer volume of data from satellites right now.
Yeah.
Weather imagery, global communications, defense.
Beaming all that raw data back down to Earth is a huge bottleneck.
Right, so if you put the AI in orbit, it processes the raw data at the source and only beams down the finished insights.
Oh, wow. Bypassing the bandwidth issue entirely?
Precisely. And the problems in space power efficiency, cooling in zero gravity, flawless reliability.
Because you can't just send a tech up to swap a hard drive.
Exactly. Those challenges are perfect mirrors of terrestrial data center struggles. It's the ultimate stress test.
As Huang said, they have engineers who can solve problems whether on Earth or in orbit.
If it survives space, it's bulletproof on the ground.
Okay, so we have the factory, the power, the cooling, and we are floating in space. Now we need the workers.
Software and physical agents.
Right. They talked about OpenClaw, calling it the operating system of the agent era. But what's this joke about everyone raising a lobster?
It's a developer joke about open source AI. Building an autonomous agent from raw code is like raising a wild lobster.
It snaps at everything and scuttles around.
Yeah, it grabs data unpredictably. It might execute perfectly, or it might accidentally delete a vital database.
Because it hallucinated a solution. That sounds like a nightmare for an enterprise company.
Which is why Nvidia launched Nimaclaw. Or, as they joked, one-click shrimp farming.
Turning the wild lobster into predictable shrimp farming. I love that.
It wraps those open source agents in enterprise-grade security and privacy sandboxes.
And they are expanding the open models too. Nematron 3 for omni understanding and voice chat.
BioNemo for drug discovery. Specifically the Proteina Complexa model.
And Cosmos 3 for physical AI. They had 110 physical robots on stage, plus Olaf from Frozen.
Yeah, the Disney integration was a fun touch.
They also introduced Isaac GR000N1.7 for humanoid robots and autonomous driving partnerships. BYD, Hyundai, Nissan, Uber.
Software won't just be a tool anymore. It'll be a digital employee.
So every SaaS company becomes an agent as a service company.
Yes. Yeah. it's inevitable.
But let me play devil's advocate. If NEMA makes deploying these agents one click, aren't we risking runaway AI?
Companies deploying AI without oversight.
Yeah, software making financial trades or steering a 2-ton vehicle on its own.
This raises an important question, actually. And it's exactly what NEMA is designed to front-run.
How so?
It defines strict operational boundaries using privacy computing modes.
So the data stays local.
Exactly. Your sensitive data stays on your secure servers. Only the encrypted computing workload goes out to the network.
So you can't have a humanoid robot hallucinating while carrying a heavy box in a warehouse.
Right. The guardrails are baked into the operating system itself.
Got it. Well, speaking of the physical world, Huang brought things back down to earth and really back to Nvidia's roots.
Gaming and graphics.
They announced DLSS 5. Huang called it the GPT moment for graphics.
The biggest breakthrough since real-time ray tracing in 2018.
The sources say it uses real-time neural rendering. It doesn't just upscale anymore, right?
Right. Older versions took a low-res image and guessed what the high-res version should look like.
To boost performance.
Yeah. But DLSS 5 completely abandons that. These are end-to-end trained AI models that literally generate complete pixels dynamically.
Based on lighting and materials, the demos for Resident Evil, Requiem, and Starfield were unreal.
Traditional rendering calculates every polygon and light source. Neural rendering is like describing the scene to an incredibly fast artist.
The AI understands the intent and generates the output.
Instantly.
But wait, if the AI is generating the pixels dynamically, doesn't this take the art out of game design?
A lot of creatives are worried about that.
Are we replacing developers with prompt engineers?
It's a vital distinction to make. DLSS 5 does not replace the artist. It merges structured data with generative AI.
Structured data being the game engine's geometry.
Exactly. The layout, the rules, the architecture, that is still meticulously designed by a human.
Okay.
The generative AI is just the ultimate rendering engine. The artist still has absolute control over intensity and local masks.
It's a tool, not a replacement. And I imagine this goes way beyond video games.
Oh, absolutely. Architectural visualization, digital twins of factories. You'll walk through a photorealistic building before ground is broken.
Proving that Nvidia hasn't forgotten the GeForce marketing campaign that built their empire.
Not at all.
So what does this all mean? We started with a massive keynote in San Jose, but this is really a blueprint for the next decade.
Nvidia is scaling vertically and horizontally at a breathtaking pace.
Conquering custom silicon with Vera Rubin and Grok, mastering gigawatt liquid cooling, building the OS for agentic AI.
Providing brains for humanoid robots and launching data centers into orbit.
Exactly. So to you, the learner, whether you're a developer, a gamer, or just living in a world powered by AI weather simulations.
Nvidia's token factory is going to be the invisible infrastructure of your daily life.
It really is.
And that leaves us with a lingering thought. Something humming beneath this entire keynote.
What's that?
If Nvidia provides the custom hardware, the cloud software, the agentic operating system, the robot brains, and the literal data centers in space,
Yeah.
at what point do they stop being the supplier of the AI revolution and simply become the sole architect of both our digital and physical reality?
Wow. If one company owns the engine, the factory, the fuel, and the roads,
Where does the infrastructure end and the application begin?
that is a question we are all going to have to grapple with very soon. To you, our listener, thank you so much for joining us on this deep dive.
Keep learning and keep exploring those sources.
We'll see you next time.